Do you know, metal plays a very important role in our life. If we observe all around us, you will find many objects are made up of metals. You might have observed your mother wearing a beautiful necklace of precious metals like gold and silver. Also, different utensils in our kitchen are made up of copper or aluminium. Also, many bridges are being constructed in different areas due to increase of urbanization, especially in cities. The main raw material used is iron. All these elements, copper, silver, gold and iron, are transition elements, and they are present in D block of the periodic table. So let's study about each of them in detail. All of you might have seen the modern periodic table, right? It contains S block, which includes group 1 and group 2, P block, which includes group 13 to 18, D block, which is located from group 3 to group 12. And the bottom we have F block elements, which include two series. One is the lanthanide series and the second one is the actinide series. In this video, we will study about the D block elements. The elements which are located from group 3 to 12 are called D block elements. The D block orbitals are progressively filled in each of the 4 long periods. They are mainly 3 series: 3D series, 4D series and 5D series. The fourth 6D series is still incomplete. The 3D series is from scandium to zinc, 4D is from yttrium to cadmium, 5th D series is from lanthanum to mercury, omitting cerium and lutetium. And the 6D series begins from actinium and is still incomplete. You don't have to remember the whole D block, but try to remember the 3D series. Can you tell me why these elements are known as D block elements? Well, this is because their valence electron enters in the outermost D orbitals. Let's write the electronic configuration of nickel. Here you can see that the valence electron enters the outermost D subshell, that is 3D. Hence, it is a D block element. Let's consider one more example. The electronic configuration of manganese is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d5. Here, the valence electron enters in the outermost D subshell, that is 3D. Hence, we can say that it is a D block element. But do you know D block elements are also called transition elements? Can you guess why it is so? It is because their position is between S and P block. They show significant transition in their properties from S block to P block elements, which are generally non-metals. Now, let's look at the exact definition of the transition metals. It is defined as one which has incomplete D orbitals and its ground state or any of its oxidation state. So, can you tell me all D block elements are called transition metals? Think. The answer to this question is no. Please note that zinc, cadmium, mercury of group 12 have full D10 configuration in their ground state as well as in their oxidation state. Hence, they are not regarded as transition metals. However, being the end member of 3 transition series, their chemistry is studied along with the chemistry of transition metals. Now, let's study the electronic configuration of D block elements. In general, the electronic configuration of these elements is N-1 D1 to 10 NS1 2, where Ns is the outermost or the valence shell which can have 1 or 2 electrons. N-1D is the penultimate shell which can have 1 to 10 electrons. But there are several exceptions to this as well. Let's understand this in detail. Consider the element chromium whose atomic number is 24. Now, if I ask you to write the electronic configuration of chromium, what will you write? Yeah, obviously it is 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d4. But do you know this is not the correct electronic configuration of chromium? Instead, the correct electronic configuration of chromium is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d5. But why this happens? This happens because this is a very little difference in the energy level of ns and n-1d orbitals. Due to inter-electronic repulsion, one electron is pushed into 3d orbitals from 4s orbital. As a result of which, the d orbitals get partially filled, and half-filled and fully filled orbitals are relatively more stable. Consider the case of copper now. The atomic number of copper is 29. The correct electronic configuration of copper is 1s2, 2s2, 2p6, 3s2, 3p6, 4s1 and 3d10. And it's not 1s2, 2s2, 2p6, 3s2, 3p6, 4s2 and 3d9 due to similar reasons. Now, can you tell whether zinc is a d block element or transition metal or both? Let me give you a hint. Just write the electronic configuration of zinc. Now, let's summarize what we have learned.
Manorama Horizon. Learning made simple.